Hello everyone. Today we do our first lecture, the unit circle. So what is a unit circle? The unit circle is a circle with a radius of 1 unit. So it goes through 1 at x-axis, at y-axis, and I'm going to say radius equals 1 unit. What is equation of unit circle? Equation. Well, you remember equation of a circle centered at origin is x squared plus y squared equals radius squared. In our case, because radius is equal to 1, 1 squared is 1. So our equation is x squared plus y squared equals 1. Now, let's check if a certain point sits on unit circle. For example, let's check if point P with coordinates 1, 0 is on a unit circle. How do we check it? Well, we just plug in the coordinates into x and y and check if we get true statement. If it's not true, then it's not on the unit circle. If it's true, it's on unit circle. I'm plugging 1 instead of x, so it's 1 squared plus 0 squared equals 1. You see it's a true statement. So the point is on unit circle. So I'm going to write down yes. Let's check another point. P equals -1, 2. Is it on the unit circle? Well, again, plug into equation. We have -1 squared plus 2 squared equals 1. Is it true? Well, -1 squared is 1, plus 2 is 4. Is it equal to 1? Obviously, this side is equal to 5 and does not equal to 1, so it's not true. So the point is not on unit circle, not on unit circle. Well, very good. Now, if we know that a certain point P with coordinates, for example, 1/2 and y, sits on unit circle, can we figure out what is y? Y is unknown. Let's try to use our equation again. So we do know that x coordinate is equal 1/2. So I'm going to put 1/2 into our equation plus y. Y is unknown. And equals to 1, right? We have equation about y, which we can solve. Move 1/2 squared, which is 1/4, to the right side. We have y squared equals 1 minus 1/4, which equals 3/4. When we extract the square root, we are going to get plus minus square root of 3/4, or plus minus square root of 3 divided over 2, right? Square root of 4 is equal to 2. So why do we get this like two different values for y? Let's just draw unit circle and see what is going to happen. Unit circle, here is 1, right? Here is x, and my point has x equals 1/2 somewhere here. Oh, maybe I should not write down 1/2 over here, actually. Here I'm planning to draw something else. Okay, let me erase it. 1/2. Oh, it's erased everything. Okay, that's not good, but let's go back to unit circle. This is 1/2. I'm going to put 1/2 over here because I need this vertical space to draw something. So x equals 1/2. What is going to be y? Well, if y sits on the unit circle, there are two possible positions for y, one on top and one on the bottom, right? My unit circle is not symmetrical, but normally on symmetrical unit circles, they are going to produce the same distance from origin. But for the below one, y is negative, right? Square root of 3/2. And for above one, it's a square root of 3/2 positive. So we do have 2 points which correspond to x equals 1/2, square root of 3/2. And I'm going to label it P1 and P2, which is going to be 1/2 minus square root of 3/2. You see? Well, now let's talk a little bit about terminal points on the unit circle. I'm moving to a different page. Let me change the color. I don't know, let's make it green. Terminal points. Terminal points in the unit circle. What are terminal points on the unit circle? Imagine that we have a unit circle. Something like this. My circles are never very good. I should turn on some function which makes circles round, right? And imagine we have a tourist, or like me, for example, and I start working from the point on x-axis on the unit circle. That's my start point. and I walk along unit circle up to certain point P. I'm going to call this point the terminal point of my kind of my path. And this point is going to have coordinates, right? And it also going to have like how far I was walking, right? We can measure the distance. Well, I'm going to kind of label this distance, the length of this arc, as t. And when I'm walking counterclockwise this direction, my t is going to be positive. And when I'm walking clockwise, let me choose a different color. If I'm walking this way, my t is going to be negative. Okay, so, well, along the circle with radius of 1 unit, how far can I walk? Well, I can make a full circle, right? What is going to be the full circles? We know that circumference of a circle is 2 pi multiplied by the radius. In our case, radius is equal to 1, so we are going to just get 2 pi. So full circle is going to be 2 pi. Now, what if I don't want to walk a full circle and I walked just like quarter of it? For example, that's a unit circle, and I started walking. Let me choose a different color, and I'm walking from my initial point here, and I finish over here, my terminal point. What are the coordinates of my terminal point first? Well, because it sits on y-axis, x is 0, and y is equal to 1, right? How far did I walk? Well, we know that the full circle is 2 pi, right? What is this? That's a quarter of a circle. So I'm going to write it down that t equals 1/4, a quarter of a whole circle c. C is equal to pi, right? The whole distance I can walk along the circle is 2 pi. So it's 1/4 multiplied by 2 pi is going to be equal what? Pi over 2. So t, which corresponds to this p 0.01, is equal to pi over 2. Well, what is going to be t if I walk opposite direction? If I do walk like this direction? Well, my t is going to be negative pi over 2, right? The distance is same, just because I'm walking clockwise, it's going to be negative. And the coordinates of my point P, which is my terminal point for my kind of walk, are going to be 0, -1, because y here is -1. I'm going to label y and x, okay? So what other possibilities we have on a unit circle? I don't want to draw 10 unit circles. I'm going to use this one until I can, and then draw another one. So what if I walk about like a half of a circle? What is going to be like, what is going to be t, and what is going to be the terminal point? Well, if I walk half of a circle, t for half of a circle is 1/2 of circumference, right? In our case, 2 pi over 2, or pi. And terminal point, which corresponds to it, is going to be what? Well, x equals -1, y equals 0, so that's a terminal point. For t equals pi. What if I kind of repeat my trick and go opposite direction like this? If I do half of a circle, I'm going to arrive at the same point, you see? And I'm going to walk the same distance. So I'm going to write down here that for t equals -pi, walking opposite direction, I'm going to have still same terminal point. Well, happens sometimes, right? What other terminal points I can have? I think we already had like pi over 4, we had pi over 2. Let's do like a 3/4 of a circle. Well, I'm going to draw a new one. A new one, that's a unit circle, right? Imagine that somebody is walking 3/4 of a circle. 3/4 means I start here, walk here, here, and finish over here. First, what are the coordinates of terminal point? We know that x here, because it sits on y-axis, equals to 0. Y is -1, right? What else? What is going to be the t? T here, it's 3/4, right? 1/4, 2/4, 3/4. 4/4 is making like full circle of circumference, which we still remember equals 2 pi. So we have 3/4 by 2 pi. 2 and 2 cancels here, and we have 3 pi over 2. So actually for t equals 3 pi over 2, p equals 0, -1. If you look at the picture over here, let me let me just point at it. If you look at the picture over here, we do have a similar point here, right? Just we arrive from the different like position, like we walk different way. We walk down and have t equals negative pi over 2. Actually, we have same terminal point for two different t's. Well, maybe I'm going to write it down just to kind of point that it's possible to have a different point, different t's. So we have t equals negative pi over 2 for this terminal point, and also t equals what? 3 pi over 2. Okay. The last example I want to consider for terminal points is going to be like, what if we do several circles? Like there is a unit circle, right? One here, x here, y here, one here. But what if we do several circles like this? We start from here and walk one circle and then do one more, and then do like maybe 3 circles, come over here somewhere. So what is going to be my path? Well, guys, we know that full circle is 2 pi, right? We need to count how many full circles we have. Well, looks like I have 1 full circle, 2 full circles, and 3 full circles. So my t is going to be equal 3 circumferences plus a quarter of a circle, 1 over 4 circumference. Well, you don't need to write down circumference every time. Circumference here we know is equal 2 pi, so we are going to have 3 by 2 pi plus 1 over 4 by 2 pi, which is going to give us 6 pi from the first term and pi over 2 from the second term, which is going to end up like, if we bring it to common denominator, it's going to be 13 pi over 2, right? 2 by 6 is 12, plus 1 more, 13 pi over 2. So t here is equal to 13 pi over 2. What is p? Well, p is going to be what? X equals 0, y equals 1. Terminal point is x equals 0, y equals 1. Okay? So we are going to consider some important terminal points. So far, guys, we were dealing with terminal points on x-axis or y-axis, right? We did quarter of a circle, half of a circle, 3/4 of a circle, several circles. Now, what is going to happen if we do something in between? Well, I'm going to label it as some important terminal points. What are some important terminal points? We are going to keep like doing division of a circle in smaller parts. So I'm going to draw my unit circle. X here, Y here, 1 here, and 1 here, right? What if I walk up to intersection of my unit circle with a line Y equals X up to here? Well, you know that this line divides my first quadrant into 2 equal parts, right? We already know that the path from initial point to terminal point here on the y-axis is pi over 2, right? If we divide it in 2, we are going to have t equals pi over 4. It's like we did a circumference and divided it over 8, right? 2 pi over 8. So this is 1/8 part of a pizza, pi over 4. What is going to be like P here? What are coordinates of the point P here? Well, because a point sits on the line y equals x means that y for this point is equal to x, repeating the same, right? I'm going to plug it into my equation. So instead of x, I'm plugging x squared, right? Just x. Instead of y, I'm going to plug in x squared again because my y equals x and equals to 1. From where I have what? 2x squared plus x squared equals 1, or x squared equals 1 over 2, or x equals plus minus square root of 1 over 2, or you can write it down like plus minus 1 over square root of 2, extracting a square root of 1. Why did we get two different x's? We do see that for this specific point, x is going to be 1 over 2, right? Where is going to be x? Not 1 over 2, 1 over square root of 2, sorry, positive 1. What is going to be x minus 1 over square root of 2? Well, if kind of I make a symmetrical point here with minus 1 over square root of 2, I'm going to get actually a point on my unit circle, which is like, let's say, some extra, right? If this is pi over 4 and the whole thing is pi, we are going to have t equals 3 pi over 4. So t up to this point is 3 pi over 4. Up to this point is just pi over 4. And x is different, right? Y is going to be same for both of them. So I'm going to write down that for p equals 1 over square root of 2x. What is going to be, by the way, y? Well, we remember y equals x. So if x equals 1 over square root of 2, then y equals 1 over square root of 2. You just need to kind of match them. So positive x is not going to be equal to negative y. They're supposed to be identical equal, right? We have t equals pi over 4. What other combinations we can have? Well, we already had one more combination, right? It was a negative 1 over 2 here, and for this one, negative 1 over square root of 2 here, right? Well, just if we sit on this line, we are going to get this point. And that's going to be what? T equals, well, it's pi and pi over 2. We are going to have 5 pi over 4. Pi and pi over 4, sorry. Now, for this point and symmetrical point over here, this is not going to be true because they are not sitting on a line y equals x. They are sitting on a line y equals negative x. So I'm going to label this line as y equals negative x. So we are going to have opposite signs of x and y. So I'm going to start with this point because I already know that t here is 3 pi over 4. We already know the coordinates, right? X is negative 1 over square root of 2, and y is going to be 1 over square root of 2. And the last point, the point over here, what is going to be x? Well, x is positive, right? Y is going to be negative because it's below x-axis, minus 1 over square root of 2. What is going to be t? Well, you see that this point is just a little bit away from x-axis. What you can write down as t is negative pi over 4 if you go this direction, right? Or if you go positive direction, it's going to be like 2 pi minus pi over 4, which is going to give you like, what, 8 pi minus pi over 4, which is like 7 pi over 4. So two different t's are going to correspond. I should probably not write them as equal. Sorry. Somehow it does not erase anything. They're not equal. They're just kind of different t for the thing. Oh, somehow I choose a different. Okay, so we know how to deal with pi over 4, and we know that there are going to be 4 symmetrical points around the circle, which are kind of dealing with same numerical number, the same numbers, but with different signs of x and y. Now, we are going to move to example number 2. Give me a new page. So example number 2 is going to deal with t equals pi over 3. What is pi over 3? It's actually circumference divided over 6. 2 pi over 6 is pi over 3. So we divide our full circle into 6 parts, like pizza divided into six pieces. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Well, on my picture, they don't look equal, but they are supposed to be equal. I'm just going to consider one part. I'm going to dismiss the rest. And I'm going to talk a little bit about this part. I'm going to connect my terminal point, my point P, for which I don't know the coordinates x and y, the question, what are x and y? I'm going to connect it to this initial point. And that makes a triangle, right? I know that in this triangle, these two sides are equal because they are radiuses of this unit circle. What can I tell about this side? Well, what I know, guys, that like the whole half of a circle or open angle is going to be pi, right? We know that the sum of angles in a triangle is equal to 180 degrees or the straight angle. So what is sum of the angles in my triangle? If I label this angle as alpha and this, because they're same, right, as alpha, I'm going to have pi over 3, this one, plus 2 alpha equals to pi, right? From where I can calculate alpha, it's pi minus pi over 3 equals 2 alpha, or 2 pi over 3 equals 2 alpha, or alpha equals pi over 3. What I have all three angles same, right? What does it mean? If all three angles are same, means that the triangle has all equal sides, and they are all equal to 1 unit. What is going to happen if I draw a median in this triangle? It's going to divide, it's going to become a median, and the height in this triangle is going to divide side in two halves, right? So it's 1/2 here and 1/2 here. That's what I'm going to do over here. Just in my case, in my triangle, this 1/2 is going to be also x coordinate of my point P. So for P, I already know that x is 1/2. Can I calculate y? Remember the first example of considering a point on unit circle when we calculated y. Remember we had y square equals plus minus a square root of 3 over 4. We just did this already. And we know that it's going to be plus minus square root of 3 over 2. Because my point sits over here, y is definitely like positive. So I'm just going to use a positive value. Okay, and I'm going to have terminal point 1 over 2 square root of 3 over 2 for t equals pi over 3. And of course, you can kind of go around for negative pi over 3, for example, and negative pi over 3 is going to be somewhere here, right? And that's going to have same x, but negative y, which is going to be this minus 1. Maybe I should write it down. So p 1/2 negative square root of 3 over 2 is going to be for t equals negative pi over 3. Okay, very good. Now one more special angle, and we are going to have our table. Example number 3. Imagine that you take this triangle and kind of shift it down. What I mean shift it down, just rotate it about the axis and draw it like this. Well, let's consider first what is going to be the terminal point here and what is going to be t. Imagine that you divide the whole circumference into 12 parts. It's going to be 2 pi over 12 equals pi over 6. Well, pi over 6 here, pi over 6 here, and that's our triangle. The very same, just kind of rotate it a little bit down. Well, because the triangle is same, all the properties of the triangle are same, which means that this one is the height, and that's going to divide this side, which is equal to 1 unit, into halves. So this is equal 1/2, which is going to be what? Y coordinate actually of my terminal point. So P is going to have unknown x and y equals 1/2. Can we calculate x? X is a question. Well, let's write down equation. X squared plus 1 over 2 squared equals 1. Equation of a unit circle from where x squared equals what? 1 minus 1 over 4 equals 3 over 4, or x equals plus minus square root of 3 over 2, right? Square root of 4 is 2. Well, because for my picture over here, x is positive, I'm going to just use positive x, and I'm going to write down that P has coordinates as square root of 3 over 2, 1 over 2 for t, which is equal pi over 6. They don't do it in your book in this section because actually we did not learn yet about triangles, but I believe that you know about triangles since middle school or high school, right? So it's not a new for you that the sum of angles in a triangle is equal 180 degrees or pi radians, okay? I'm going to put a table for important points for the first quadrant. But first, what is first quadrant? Let me shade it. So guys, this is called first quadrant. You probably know this. I'm going to put Roman numeral one quadrant. This is called the second quadrant. This is called the third one. This is called the fourth one. Well, if you don't know this, like Roman numerals, you just can use 1, 2, 3, 4. It doesn't matter actually. Just can tell the first quadrant, second, or third, or fourth. They just kind of, because they are counting quadrants, not adding them together. They use kind of different numbers. Okay, so I'm going to put a table for terminal points in the first quadrant. I'll need a new page. So, table for coordinates of terminal points in the first quadrant. Well, table is very simple. We don't have that many points, right? I'm going to start with t, and over here I'm going to put the coordinates. My first point is 0. When t is equal 0, actually we don't move anywhere, right? We stay at our original point, and it has coordinates 1, 0, x equals 1, and y equals 0. We move to pi over 6, our last example. What were the coordinates? At pi over 6, x was a square root of 3 over 2, and y was 1 over 2, right? At pi over 4, our first example, x was 1 over square root of 2. Wanted to write down actually a square root. Somehow my eraser does not work with this whiteboard. Well, that's okay. 1 over square root of 2, 1 over square root of 2. And the next one is pi over 3 was example 2. And we have 1 over 2, sorry, missing parenthesis here, a square root of 3 over 2. And the last one is going to be pi over 2, which is going to be the point on y-axis, which is x equals 0, y equals 1. Guys, I want you to memorize this table, very useful table when you deal with trigonometry and specific angles. We are going to deal a lot with this kind of angles, so makes sense to remember the table. Okay, so how do we use this table? Well, for example of use, somebody gives us t equals minus 5 pi over 4, and they're asking what are the coordinates of x and y of the terminal point. You kind of draw a number circle, and just you'll need to figure out like minus 5 pi over 4, what is it? Well, minus 5 pi over 4, it's almost like pi plus pi over 4, just was minus. If you bring it to common denominator, it's 4 pi, 5 pi over 4, 4 pi plus pi, 5 pi over 4, right? So we kind of, on a unit circle, we go pi, which is half of a circle, and go like 1/4 more. Just because it has minus, we have to move in opposite direction. So we go half of a circle and quarter more. So this is going to be the terminal point P. This one was plus and this one was minus. Okay, so I'm going to maybe kind of show this arrow like where we are. Now, what are going to be the coordinates? Well, we know that this length is pi over 4, which means that it's going to produce very same coordinates as original pi over 4 is producing. Let's search for pi over 4 here. The coordinates are 1 over square root of 2 and 1 over square root of 2. For this point, the coordinates x is going to change the sign, right? Because it sits on negative x-axis. So it's negative 1 over square root of 2. Y is going to be same, 1 over square root of 2. And for point P, we are going to write the coordinates minus 1 over square root of 2, 1 over square root of 2. Okay, well, we are using some symmetry properties of the triangles and everything, right? Now, the last thing in this section is a reference number. What is a reference number? Well, maybe I should explain it using the very same picture. Reference number is the shortest distance from the point. Imagine point sits over here, right? To x-axis. Well, in this case, the shortest distance is this, right? We are going to call it a reference number. And we are going to put t with bar for reference number. In this case, reference number is pi over 4. Reference number is always going to be positive. It's just like you measure the distance with ruler, and ruler is always going to give you a positive number, right? You never can have like -5 kilometers or -3 centimeters. Okay, so how reference number is helpful? Well, reference number is actually going to point to the value from the table for which we are going to use the numbers. And we just need to check where the point sits. Is it in the first quadrant, second, third, or fourth? Because we know that x, so both values are positive here, right? And then x is negative here and y is positive, and then all are negative here in the third quadrant, and x is positive and y is negative here. So we are going to use the same point, the same numbers as a reference number, but we are going to adjust the sign of the numbers to the quadrant where it sits. I'm going to consider one example using of reference number. Example, imagine that somebody gives us t equals 7 pi over 4, and they're asking us, okay, what is pxy? What are the coordinates of terminal point? Well, you kind of imagine like, okay, what is this? How this angle looks? 7 pi over 4. It's almost 8 pi over 4, right? So what is 8 pi over 4? 8 pi over 4 is 2 pi, right? A full circle. 7 pi over 4 is a little bit less, 1/4 less, right? So it's 7 pi over 4. It's 2 pi minus pi over 4. So what is missing from this point to the x-axis? Well, pi over 4. So my reference number is pi over 4. So again, I'm going to use these two numbers as coordinates. Just I remember that my signs are plus and minus. Here are plus plus, but for this quadrant, it's plus and minus. So I'm going to write down 1 over square root of 2 minus 1 over square root of 2 minus 4y. You see? Very easy to kind of use. What if you have like big angles, like for example, one more example. What if your t is equal something like 13 pi over 4? For 13 pi over 4, we are going to kind of subtract as many pi's or 2 pi's. So for example, here what we have, if we kind of divide 13 over 4 with remainder, we are going to have what? 12 over 4 plus 1 over 4, right? Pi. Or we have 12 over 4 is 3 pi plus pi over 4. Well, if you draw a picture, what is 3 pi? 3 pi, it's a 1 pi, 2 pi, and 3 pi. Again, back over here, 3 pi. If you do one extra pi over 4, you're going to arrive over here. So the point sits here in the third quadrant, right? Well, terminal reference number, sorry, over here is going to be t bar pi over 4 because that's how far it's from the x-axis. So we're again going to use the same numbers, but the coordinates are going to have all minuses, right? Minus here and minus here. So I'm going to have minus 1 over square root of 2 minus 1 over square root of 2. That's going to be my p, which corresponds to t 13 pi over 4. Okay. Well, I think that's all from section 1. My suggestion is to read the book too, not only kind of follow my lectures, read the book too, and maybe look through my notes. If you don't have time to watch my lectures, do the homework and take a quiz. Okay, and I have all the directions so you can kind of follow directions. Thank you, and I think we are going to stop at this point.